Hi, this is Kevin Buzzard recording solutions to section 9 of my Formalising Mathematics 2022 course, and this is me showing the issues involved. I mean, look, these are the same thing, right, to a mathematician. A function from x to y is bijective if and only if it has a two-sided inverse. Those are the same thing, so it should be pretty straightforward to prove, right? But actually, one direction of this implication is equivalent to the axiom of choice. So there's some little, I mean, that's not an issue, but it means you have to know what to do, basically. So let's split this argument and let's prove both directions independently. So firstly, we'll do the easy way. Let's assume that there exists a G, which is a two-sided inverse to f, and let's prove that f is bijective. So let's assume that G exists and whatever, h1, h2, and it's a left inverse and a right inverse. Now, how are we going to prove that f is bijective? Well, I guess that bijective means injective and surjective, so we could split again. Now we've got two goals. Prove that f is injective and surjective, and I've put those two goals in brackets. So how are we going to prove that f is injective? So let's take two elements a and b of x and the hypothesis that f of a equals f of b, and now we want to deduce that a equals b. I guess an easy way of doing that was, we know that f of a equals f of b, so we can deduce that g of f of a equals g of f of b by applying g to both sides of h. So apply fun g at h. There we go. And now g of f of a equals g of f of b. And now hypothesis h2 says that g of f of x equals x. So we can rewrite h2. We've got to do it twice, I guess. Rewrite h2 at x. Sorry, at h. And now the hypothesis h has become equal to the goal. So in fact, instead of doing assumption, we could use the RWA tactic, which is rewrite and then try the assumption tactic. So there's injectivity. And surjectivity, what does that mean? It means for all y there exists an x, so let's choose a y. Let's spell the tactic correctly. Let's choose a y. Now where's the x coming from? We've got an element of y, we need an element of x. It's obviously going to be g of y, right? So let's use g of y. And now I've got to prove that f of g of y is y, and that's exactly hypothesis h1. So there we go. So that's the easy way. If a function's got a two-sided inverse, then it's bijective. And now the trickier way, I mean not that much trickier, but you need to know the technique. If a function's bijective, then where's this two-sided inverse coming from? So we can, what can we do? We can rintro h1 and h2. So hypothesis h2 is the hypothesis that f is surjective. So let me just show you what that says. Let's just unfold it. It says for all b and y there exists an a and x such that f of a is b, and obviously the function we want is that given a b and y we want that a and x, right? That's what the function we need is. So we need to use a tactic I've not talked about before, the choose tactic. So we can choose g hg using h2, and there it is. G is the function from y to x, and hg is the hypothesis that for all b and y, f of g of b is b. So now what? So we're trying to prove that there exists a g such that blah blah blah, and now we have it, so let's use that g. And now I've got to prove two things. That it's a left inverse and a right inverse. So this one is the one we have already. That's exact hg. I mean, in fact, it split an exact hg. We could probably have done refine hg comma underscore then instead of split, right? Yeah. We don't have to there. We don't have to split and then put more brackets in because one of our proofs was just hg, so we may as well just insert the proof hg immediately. And so now here's a little bit of a puzzle, right? We know that f is injective, and we know that for all b and y, f of g of b is b. And now we want to prove for all x and x, g of f of x is x. So we better start by intro x, so let little x be an arbitrary element of capital X, we've got to prove that g of f of x is x. And I guess, you see, all we can use is that f of g of b is b, right? That's the only thing we know, basically. And we're going to apply that to an element of y, and the only element of y we can make is f of x. So, I mean, we could, if you like, specialise hg f of x. And that's what you see, that's what we have. F of g of f of x equals f of x. That's basically the only fact we know. But then f is injective, you see. So that will give us that g of f of x is x. So I guess we could apply h1. And now our assumption, now our goal is an assumption. So exact hg. So that's done that one. I mean, this could be tidied up a bit, but you know, somehow this choose tactic was the thing I wanted to show you. Right, that's it for that sheet. Thanks a lot for watching.